どうも皆さん、英語で数学、瀬戸です。今日は関数の基本についてレクチャーをしたいと思います。In this video, we'd like to go over some facts about functions. So first of all, what is a function? Here is the definition. A function f is a rule that assigns to each element x in a set D, the domain, exactly one element, f of x, in the range. There are many examples of functions. One example, let's say, is the height of a ball that you throw up in the air at time t. So, in this case, the domain would be time, and the range would be the height of the ball. So, for example, suppose the value of h at 0 equals 3 meters. What does this mean? This means that at time t equals 0, the ball is at height 3 meters. Well, what about h of 1 equals 4? Well, we haven't really made clear what we mean by 0 and 1 for t, so let's just say it's going to be 1 second. So that t is in seconds, then this would just be after 1 second, the ball is at a height of 4 meters. Now, how can we represent functions? For instance, this function h of t, which I've made a little bit more precise now, the value of the function will be in meters, and that's the height of the ball, and after t seconds after you launch it or throw it. Well, we can represent it in a couple of different ways. We can verbally say that, like h of 0 is something, 3, h of 1 is 4, but then it would be kind of hard to do calculations with it if you have to keep saying what the value of the function is. So you can describe it algebraically, so maybe something like h of t equals t plus 3. So that h of 0 is you replace t with 0, so the value will be 3, or h of 1, you replace the t with a 1, so you get 4, and you can replace this with any other number. Another way to represent this function is by its graph. So how to plot these functions is you look at the t-axis, and we're saying that at t equals 0, the height is 3. So at t equals 0, this will be at 3. At t equals 1, this will be at 4. At t equals 2, this will be 2 plus 3. So this will be 5. And actually, this is an equation of a line. So you can just connect the dots by a straight line, like this. And the novelty of representing it by a graph is that you can kind of see the behavior of this function in between the specific points. So, like h of 1/2 or 0.5. While you can just plug it into the algebraic expression, you also know that 0.5 is somewhere between here. So you kind of know that the height is between 3 and 4, somewhere there. So a lot of times you don't really need to know the precise value. You just need to know the overall behavior. So for things like that, the graph might help. But for a function as simple as this, maybe it is better just to plug it in. So it's 3.5. This is not a realistic function describing the height of a ball. Well, it might be kind of hard to tell just by looking at this algebraic expression. But if you look at the graph, it's just a straight line going up. So that means that the height of the ball just keeps going up and up and up, which, well, what comes up must go down. So this is not really a realistic function that describes the height of a ball. Now, suppose we are given a graph. How can we tell if this graph is a graph of a function? Remember that a function must have exactly one output for each input. So in the previous example, with the height of a ball, it wouldn't make sense if h of 1 was 4 or 5. So after 1 second, is it 4 meters or 5 meters? It has to just be one output. So is this the graph of a function? Well, let's try to read this. At t equals 1, this may be function f, right? The value of f of 1. Well, we could argue it's this, whatever number this is. Let's just say 2. But we could also argue that it's this, Who's correct? Well, so it looks like this relationship is assigning the value t equals 1 to 2 and negative 2. So this is not a function. One quick way to tell if a given graph is a representation of a function is if it passes the vertical line test. So we draw a vertical line. If it intersects more than once, then this is not a function. Now suppose we have a function, but we modify it a little bit, then how does it affect the graph of its function? Well, here are some of the lists of the possible transformations. I mean, there's more, but here are the basic ones. So you have the horizontal and vertical shifts, and also the vertical and horizontal stretchings. So here's one example. Let's say that we are given the function the square root of x, and the graph y equals root x looks something like this. Then, what would the graph of y equals square root of 2 minus x plus 1 look like? We can think of this as a transformation of the square root graph because we're multiplying the inside by negative 1, and then we're adding the inside by plus 2, and then we're adding 1 to the outside part of this function. So for this, multiplying by negative 1 on the inside will reflect this. After reflection, we're adding this by 2. So this will shift it either to the left or to the right. Now this one is a little bit tricky because you have to actually view it like this. It's going to be negative and then parentheses x minus 2. But that's not too bad because you just kind of plug in values that are important. Namely, this point here is when the inside of the square root is 0. So here, when x is equal to 2, then you have minus 2 plus 2, and so that's 0. So this point, let's call it the vertex, will now correspond to 2. So it'll shift over to the right 2. Now if we read it like this with the parentheses, then the minus 2 makes it so that we shift it to the right by 2. And then the plus 1 here just shifts it up. So by following the rules, if we know the shapes of the graphs of your basic functions, you can graph the modified ones by doing the appropriate transformation to the graph.